I'm Brendan Weger, Technical Director at Composites Evolution. We're an SME based in Chesterfield in the UK, and we develop and produce lightweight, high-performance composite materials. And these materials are used to make components in automotive, motorsport, aerospace and sporting goods. Our main product range are composite prepregs. Prepregs are reinforcement fibers or fabrics that have been pre-impregnated with a resin. The fibers can be carbon fiber or glass fiber, and the resins could be epoxy or a different type of resin. And they're a flexible, tacky intermediate material that our customers cut and mold and cure into components using press molding process or autoclave molding process to make the parts. We are one of the industrial user partners in the OntoTrans European project. OntoTrans is a project that involves 11 partners across Europe, including ontology specialists, software developers, and industrial partners. The overall aim of the OntoTrans project is to help industry to respond to manufacturing challenges more efficiently by developing tools which connect the end users with relevant data and materials models. OntoTrans is developing an ontology-based open translation environment which will support the development of dedicated apps for delivering smart guidance for materials producers and product manufacturers. The project is using artificial intelligence approaches which will enable end users to represent their manufacturing process challenges in a standard ontological form and connect them with relevant information sources and materials modeling solutions to support materials and process development and also to help optimize the processes. As an SME, we have limited resources. We don't have modeling specialists in-house, and therefore OntoTrans provides a great opportunity for us to work with experts and translators to develop user-friendly software tools that will help us with our product development process. We are providing one of the application cases for the project, and it's a particular manufacturing challenge that we have. One of the products that we produce, one of the prepregs, uses a bio-based resin called polyfurfuryl alcohol, and it comes from a waste product of sugar production. Now, this resin, aside from being renewable and sustainable, is actually fire retardant, and that makes it a viable alternative to phenolic resins, which are used widely in aircraft and train interiors where fire performance is really important. But phenolic resins are hazardous to health. Now, with phenolics and with this polyfurfuryl alcohol bioresin, they both cure using a condensation reaction, and that means that it generates water during the curing process. And at high temperatures, this water turns to steam, and that can create porosity in panels and molded parts like this one. And that porosity can cause reduced strength and surface finish issues that then need to be reworked to make a nice surface finish. And the current process to develop the material, to develop the molding process to give good quality parts is quite time intensive. It's a trial and error approach. With the help of Fraunhofer IFAM in Bremen, who are another partner in the OntoTrans project, we'll be using molecular models and data-driven models to better understand the effect of different process parameters on the porosity and the mechanical properties. And this will help us to develop and optimize our materials and help our customers get the best results. OntoTrans will help us in several ways. First of all, it will improve our understanding and control of the raw materials and processes that we use. It will improve the quality of the end products. It will significantly reduce the development time and costs of development compared to the trial and error approach. And it will create a model-based approach that we can use for future product developments, which will help us become more innovative, efficient, and competitive in the market.